After many years of study, development and testing, the European Space Agency's Jupiter Icy Moons Explorer, JUICE, has finally arrived at Europe's Spaceport in Kourou, French Guiana. Here, engineers will perform some final tests and fuel the spacecraft before it's mounted onto an Ariane 5 rocket for its scheduled launch in April. Before the spacecraft was transported to French Guiana, it passed a few milestones. In December 2022, it completed its last thermal vacuum test in an Airbus Defence and Space facility in Toulouse.
Thermal test is very important because it's the test which confirms that the spacecraft can survive and work in the environment that it will see in space, so very cold and vacuum. We already did a thermal test 2 years ago, but we decided to repeat it because 4 important instruments were not available. The test in December went very, very well.
In Toulouse, JUICE also underwent a final software verification test, during which the spacecraft was controlled from ESA's ESOC Mission Control Center in Darmstadt, Germany. Mission controllers simulated sending and receiving commands to and from the spacecraft during the launch and early operations phase of the mission. The crucial moment during this period will be the deployment of JUICE's enormous solar arrays, designed to power the mission in the dark reaches of the outer solar system. Folded up like a complex origami box for launch, they will need to correctly unfurl and at just the right angle, or the spacecraft could overheat. Once JUICE is safely powered by the sun, it will be ready to begin its epic 8-year-long and extremely complex journey to Jupiter and its icy moons, Europa, Callisto and Ganymede.
The complexity of this mission is that it has very difficult traveling to Jupiter. There are a lot of flyby of the planet, of the inner solar system and of the moon of Jupiter. All that generates a lot of stress from the point of view of flight dynamic and mission analysis. Therefore, the team has to become familiar with this element, and this is done initially by running the operation using a twin of the spacecraft, a digital twin of the spacecraft. But later on, when the spacecraft will be in flight, we will use an engineering model, which is kind of hardware brother of the spacecraft, which is used to debug the key operational procedure.
This revolutionary mission to the Jupiter system is a key part of ESA's Cosmic Vision program, addressing 2 of its core themes. How does the solar system work, and what are the conditions for planet formation and the emergence of life? By studying Jupiter both as a planet and as a whole system, JUICE will teach us more about how planetary systems like Jupiter's work in our solar system and beyond. The exploration of Jupiter's icy moons, Ganymede, Callisto and Europa, could provide insight into the possible emergence of life, as we believe that these frozen worlds hold an abundance of water beneath their ice crusts.
Certainly one of the most exciting elements of the mission would be when we enter in orbit around Ganymede, and we will do a real deep map and tomography of the moon. Ganymede is a very large moon, is bigger than Mercury. We know that there is a lot of water, and like in Earth, there is a magnetic field which is protecting the surface from the radiation from space.
JUICE is a prime example of international collaboration between industry, institutions and agencies. The spacecraft will be the heaviest mission ESA has launched to deep space. It has solar arrays measuring a whopping 85 square meters and will be the first spacecraft to orbit a moon other than our own. With its arrival at Europe's Spaceport, JUICE takes another step towards its highly anticipated April launch, the beginning of its voyage to the largest planet of our solar system.